My name is Stephen Hoskins. I'm Director of the Centre for Fine Print Research at the University of the West of England in Bristol. 3D printing was first invented in 1976. Commercial printing machines that produced plastic prototypes didn't come onto the market until the mid-1990s. 3D printing in itself has a number of different processes and means by which it produces 3D models. You can print in metal, you can print in plastics, and you can print in what are known as photopolymeric materials, which are hardened with light. This was a specific follow-on grant from our first larger AHRC grant, which was about 3D printing for artists and craftspeople and whether we could make 3D printed or rapid prototyping artifacts for artists and craftspeople. The follow-on fund was to develop that work in fired ceramics in relation with industry and whether we could 3D print ceramic prototypes specifically for the ceramic industry. AHRC funding has allowed us to explore the potential of 3D printing in ceramic because it doesn't come with the usual constraints with industry. It's much more pure research funding for us, so we can develop ideas and processes in a research manner which might not actually even work. We are artists and craftspeople, so the benefits for artists and craftspeople really come through in that ability to really look at pure research. In order to explain the move from prototypes to actual objects, which was assisted by the AHRC funding, it's best to talk about physical materials, real materials. We can now actually print in a real ceramic material that has the same aesthetic and quality as other ceramics do, whereas previously for prototypes you're printing in plastic or plaster materials, which don't have the same surface feel or quality or tactility. So that it allows people to be able to print an object with just that right look, feel and aesthetic that you wouldn't get in any other way. The partnership with Denby has allowed us to actually take industrial trials and prototypes, print them and take them back to a company who really need to use them within their process. So we've had to push the quality up and the ability to actually match their criteria very carefully. That's meant a whole new methods, structure, and they could test them for us. They gave us designs and prototypes which we could trial through our process, and then it would have to meet commercial criteria. So that we had to be able to design to a much higher level and produce prototypes that worked in a finished way. To describe the process of how it's made, our particular process uses a powder. There are printers that deposit plastics, there are printers that will print in metal, and there are printers that build up in various ways using photopolymeric materials. But to put it simply, we have a bin, a box of powder, and if you imagine that box being quite empty with a plate at the top of the box, you have a thin layer of ceramic powder. If you're printing a cup or a plate, you print a small ring at the very bottom, one thin layer at the bottom of that cup or plate. And then it drops down one step and we push some more powder over the top. Then it will drop down another step and push more powder over the top. And you print one single layer at a time and slowly build your object up in thin layers, which is why you can print incredibly complex shapes, because they're just supported all the way around by powder as this shape keeps dropping down. Finally, when the whole thing's printed, it's left to dry in the bin of powder, and then after an hour or so, you lift the whole plate out and dust all the powder off from the object, and in the middle of there, you have an object. That object needs drying further, so we put it in an oven to make sure it's really quite solid, before we then put it into the kiln and fire it. That's known as a biscuit firing, the first firing. And at this stage, that's where it becomes same as a normal ceramic process, because you would have a biscuit firing in ceramics. So we biscuit fire it to a temperature and then take it out of there. You can then glaze the object and refire at a higher temperature for the glaze to go over the ceramic object. And then you can have a third firing if you decorate, where you would refire to the decoration on top. But you will always have at least 2 firings. In terms of timescale of seeing 3D printed ceramics being commercially available, I think you have to remember that this is a research process. And even though we've worked with Denby, we've got a much further level, it isn't yet really very commercially available. So my guess is the timescale will probably be 15 years before you'd really see easily available product. Having said that, the interest is enormous globally in real materials in 3D printing. And maybe in the short term it will be used, as Denby are going to use it, as prototyping for trialling things before they make production runs. The future for 3D printed ceramic items outside of tableware is really broad. Areas at the moment we've had interest are things from uses of Ministry of Defence, where things might be armour, medical. A wide variety of people have already come and inquired. We've been surprised by the breadth of people that have come to talk to us about our ability to print ceramics. In terms of new developments that the AHRC are funding, and in the last couple of weeks, we've just heard that we've got a large grant for 3D printed self-glazing material based on an ancient Egyptian recipe called faience, known as Egyptian paste. We're really excited about this because we can actually, in theory, take a ceramic material, print it in our 3D printers, take it out of the 3D printer and put it in the kiln and fire it, and it will glaze itself. So the idea is a self-glazing 3D printing material, which is just one firing instead of the 2 or 3 that you would normally do. And the idea that this is an ancient Egyptian recipe initially is really exciting for us. I see the future of this technology as being very disruptive. It's always hard to make a prediction because you're probably going to be wrong, and these things always change in a way that you never imagine. My guess is it'll be a technology where you'll perhaps order a part online and it will appear from the post and it'll have been printed by a 3D printer. I suspect the way the technology is going at the higher end, much like our technology, it's too expensive to be a home item. But you'll certainly, there's no transport needs, there's less stocking needs. You'll have somewhere that has bulk materials and a printer, which will just print you parts, and you'll just order them and they'll arrive, and you'll have no idea that they're 3D printed, but they will be, and it will be a very changing technology for the future.